Yeah, good afternoon all. Yes, so myself, I'm Vijay. Like I hold like 17 plus years of experience, which includes 8 plus years of experience in big data, Hadoop and Spark environment, right? So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not, right? Yes.
Yes, visible. Yes, visible.
Fine, thank you. So what is big data? Why Hadoop and Spark? Drawbacks with the current databases. Hadoop and Spark, right? Advantages. And need for PySpark. Hadoop and Spark job market, right? Yes. So as part of this course, we'll be discussing like Hadoop and Spark, right? Spark with Python implementation, PySpark, right? Fine. So first, what is big data, right? The name is saying like huge volumes of data. Currently, how the data is getting stored, right? What are the data storage units like KBs of data, MBs of data, GB, gigabytes, terabytes, petabytes, exabytes, zettabytes, etabytes, ottabytes, so on, right? So from TB onwards, we say like huge data. See, TB onwards, right? Yes. But do you think like petabytes or exabytes of data is it getting generated in the current real world? Means yes, 1 petabyte equal to 1024 TBs. Already 1 TB is a large storage unit, right? Yes. So examples of petabytes of data generation, anyone, right? Petabytes of data generation, examples of any application generating like petabytes of data. So if you talk about any banking sector, right? Take the example HDFC or SBI bank, right? So take the example of this SBI, right? Fine. Within the city, we observe like hundreds of branches for this bank like SBI. Within the entire state, we see like thousands of branches, and for the entire country, you see like lakhs of branches for SBI. Again, within the each branch, we have got millions of customers making multiple transactions per hour, per day, per week, per month, per year. Each and every transaction has to be stored, right? So huge data is getting generated. Yes. Forget about this banking sector. Everyone, you are aware about social media like Facebook, right? It has got millions and trillions of users, not only within the country, throughout the world, right? In a minute, how many posts and videos are getting circulated? What should be the storage capacity? What is the data generated by Facebook in a minute? Is it in MBs or in GBs, right? TBs or in petabytes of data? Not only like Facebook, right? In today's, like we see like many applications, they are generating data, huge data in petabytes, right? Yes. If I talk like just observe this 1 minute 1 minute transaction, just to take 1 minute transaction and observe, like you see like huge data is getting generated. Example like Facebook, in a minute the data generated by Facebook, right? Yes. Or if you talk about the Twitter tweets keeps on generating, or the Google queries, everyone querying in the Google, right? Yes, Google queries. Or if you talk about that you are creating your own videos and uploading in the YouTube, right? YouTube videos upload, right? And millions and trillions of users using email or Gmail messaging, right? Yes. Just now I was talking about the bank transactions and this telecom transactions, right? Yes. And e-commerce sites like Flipkart, Amazon, right? Everywhere we see like huge data is getting generated, right? Yes. So currently we have got some databases for storing those data, right? We have got some databases like if you talk databases, Oracle, MySQL, DB2, SQL Server, right? These databases, etc. All these they are used for OLTP, online transactional processing for day-to-day operations, right? But we have got some specialized databases. We have got some specialized databases, right? Used for data warehouse purposes, right? Specialized databases. Right? Like if you have heard about this Teradata, Netija, Vertica. Vertica, right? Yes. These are used for DWH, data warehouse purpose, right? Analytical processing, right? Yes. But these databases and specialized databases, they can handle data up to some extent. Beyond that, they cannot handle the data, right? Unlimited data storage and processing can't be happened. So as a solution to this, right, storage and processing related problems, we have got a framework called Hadoop, right? Stores unlimited data storage and unlimited data processing, right? Later I'll come back what are the services provided by it. So but before that, you need to know something about the data generation, how the data is getting generated currently, different sources of it, different types, right? Assume this is the data, this is the data present in the current world, right? Current real world. This is the data which got generated from the last 50 years, assume like from 1973 to 2023, right? If you observe like this is 2013 to 2023, last 10 years, and you observe this previous 40 years of data, previous 40 years comparison with the previous 10 years, right? So nearly if you see 80% of the data what we see is generated from the last 10 years, and only 20% has been generated from the previous 40 years, right? Yes. Reasons for huge data generation, especially from the last 10 years, right? Because of usage of technology, right? Usage of smartphones, usage of internet, right? Everything through online, right? Online banking, online shopping, online exams, online healthcare, online communication, audio, video chatting, everything through online. So if you see what are the main sources from where we can get this data is getting generated, means mainly three sources of data you can see, right? Three sources of data, like yes, social data, I can say social data. Secondly, like machine data. And transactional data. Social data means data which got generated from social sites, right? Websites, Facebook, Twitter, all this, right? Machine data means data which got generated by reading or scanning the barcodes, RFID chips, all this such kind of data we call like machine data. For example, if you go to a shopping mall, for the items you purchase, you get a big bill gets generated, right? Yes, data which got generated by reading or scanning the barcodes, right? Transactional data, day-to-day operations, like bank transactions, telecom transactions, right? Yes. And mainly three types of data, right? Yes. Structured data, yes. Structured data, semi-structured, and third, like unstructured data, right? Yes. So yes, three types of data, right? Yes. Structured, semi-structured, and unstructured. Data which is organized in the form of rows and columns. Data which is organized in the form of rows and columns in a structured manner like Excel sheets, database, Excel sheets, database tables, right? Yes, DB tables. Semi-structured means which are not fully structured, which are not fully unstructured, like XML files, JSON files, right? This unstructured data like short messages, articles, right? So this demo goes right. So for first 1.5 hours, right? After 1.5 hours, we'll have a break for 10-15 minutes. Again, it goes for 1.5 hours more, right? Yes. Short messages, articles, images, videos, short messages, articles, images, videos. All these are unstructured data, right? Yes. Okay. So today the biggest challenge is to handle this unstructured data, because today most of the time the data which is generated is unstructured and semi-structured, right? So databases can handle only structured data, cannot handle this unstructured or semi-structured kind of data, right? Yes. So but Hadoop can handle all varieties of data, right? Yes. So as day by day data is increasing enormously, right? We need to have some proper storage systems, right, to handle this data and to process this data, right? As a solution to all these storage level problems and processing level problems, right? We have got a framework called Hadoop, right? It is a framework, right? So it is going to perform two things like storage and processing. If you talk about any technology, it performs either storage or processing. If you talk about or C++ or Java, all this .NET, all this, they are meant for processing. And if you talk like Oracle, MySQL, DB2, all this, they are meant for storage. Okay, they're meant for processing. So here, but Hadoop is meant for both storage and processing. The other technologies, right, they are meant either for processing or for storage, but Hadoop performs both storage and processing. Yes, Python also for processing, right? Yes. You may ask, you may get one query, right? When Hadoop is able to perform the storage and processing, what is the necessity of this, right? This processing and storage technologies, they will be away from the market when Hadoop is in the market, right? No, you need to understand clearly Hadoop is meant for what kind of applications. Hadoop is meant for batch applications. Hadoop is not for batch applications. For a single record or one record, two records, no, we don't need to go for Hadoop, right? Yes, we need to go. Hadoop is meant for batch applications. For millions and trillions of records, right? Go for Hadoop. Not for one record or two records. You can go with the databases. So for storing the data, does Hadoop use any database internally? Means no, it uses a kind of file system called as Hadoop distributed file system, right? Doesn't use any database because databases has got some problems. I said, despite of these problems, still Hadoop doesn't goes with any databases, right? Yes. And for processing, does it use any technologies? Means it's going with the execution model called as MapReduce, and now currently going with Spark, right? Spark, very high speed processing models, right? Yes. So both Hadoop and okay, fine. Spark can combinedly both store and process the data, right? Yes. And here I when talked about Hadoop can perform only batch applications, right? Hadoop can perform only batch applications. There are two types of applications, mainly we can say two types of applications. online applications. Secondly, like batch applications. User interactive applications, right? Yes. Here, user gives the input. User interactive applications. User gives the input. Yes. Example like booking a movie ticket, making a online transaction. Means user compulsory required here, right? But batch applications means user nowhere required. User non-interactive applications. User non-interactive applications. User interactive applications, user gives the input. Here user non-interactive applications. Here user is nowhere required, right? Batch applications. For example, railway ticketing PNR status, right? PNR status. Currently the status is 200. After 2 hours it is 150. Tomorrow morning it is 100. Tomorrow evening you got confirmed, right? Means this is happening in the background, right? Here user is no way required. Most of these financial applications, banking applications are background, right? Background or batch applications. Fine. Example of this batch applications, right? Generating credit bill statement for millions of customers. Bank statement generation for millions of customers, right? These are batch applications, right? Yes. Yeah. Coming to this, right? Yes. Drawbacks with the current databases, right? Drawbacks with the current databases. Drawbacks with the current databases, right? Firstly, limited storage. Most of the databases, no parallel processing. Limited storage, no parallel processing. Okay. As volume increases, right? Speed decreases. For example, if I take a SQL query, right? I want select the total amount, right? Sum of amount, total amount, right? From total amount from sales 1. Select total amount from sales 2. Total amount from sales 2. Select total amount from sales 3. I've taken 3 queries, right? Total amount I want from sales 1 table, sales 2 and sales 3. Okay, here you think in sales 1 has got 10 records. It has got 10 records. It has got like 1 lakh records. And this has got like 1 crore records. Parallel processing means that your data is stored in multiple systems and processed by multiple systems parallelly. Your job is done by multiple systems running parallelly and processing it parallelly, right? Means your data is distributed across multiple systems and multiple systems are running parallelly in executing this. Select sum of amount from sales 3, right? Yes. 1 crore records, right? Yes. Yeah, just a second, right? What is the course content? What are the things I'll be covering, right? So 1 crore records. So which query executes faster among these 3? Sum of amount from sales 1, sum of amount from sales 2, amount from sales 3. This 10 records, 1 lakh records, 1 crore records, right? Yes. Yes. Okay. Which query executes faster among these 3, right? Total amount of sales 1, of total amount of 1 lakh, or total amount of 1 crore. This first query executes faster, right? Because total amount of 10 records only. This total amount of 1 lakh, total amount of 1 crore. So query to query, as the volume increasing, speed decreasing, right? Query to query, as the volume increases, speed decreases, right? Yes. Now, one more drawback of this, right? As the complexity increases, as the complexity increases, speed decreases, right? Yes. As the complexity increases, speed decreases, right? Yes. I will take the same query, right? Yes, select sum of amount from sales 1, right? So this complexity increasing, 'total amount from sales 1, total amount from, okay, total amount, total select sum of amount from sales 1, sum of amount from sales 1, but not sum, right? Average amount, I'll take average amount, the standard deviation of amount, right? Yes. Standard deviation of amount from sales 1. Now see this sum of amount, average amount, standard deviation of amount, right? Which query execute faster among these 3? Average amount is a 2-step process, right? First sum to be calculated, next average to be calculated. Standard deviation is lot of internal processing required. So query to query, as volume increases or complexity increases, speed decreases, right? And the major drawback with databases can handle only structured data. They can handle only structured data. They cannot handle unstructured or semi-structured data. Can handle only structured data. For example, if you want to take reviews for a particular movie, right? Think that there is a table called reviews. This is the table, right? Yes. User review, right? Yes. Hundred users, right? First person saying, right, movie is good. Second person saying movie is not good. Okay. For example, they are giving reviews in the form of 0, 1, 0, 1, right? Assume if 0 means bad, 1 means good. 0 means bad, 1 means good. Okay. Can you write an SQL query to count the number of zeros and ones means? Yes, right? We can write an SQL query to count the number of zeros and ones. Count aggregation, select. I want review wise count. I want review wise count star. I want from reviews table. Group by review. Group by review, right? Yes. The output if is check, right? Yes. Reviews 1 and 0. 90 people saying the movie good. 10% saying the movie is bad. But generally reviews won't be given in the form of zeros and ones, right? They will write in their own text format. First person saying movie is good. Second person saying movie is not good. Right. Third person saying in their own text format, right? Can you write an SQL query to count the number of goods, number of not goods, right? Not possible to handle such kind of data, right? Means even if you say keyword count, it gives wrong computation because good, if you see the count of good, even not good has got good within it, right? It also will be considered. So it's wrong computation, right? Yes. So it cannot handle. So the major drawback with the databases only structured data, complexity speed decreases, volume increases, speed decreases, no parallel processing and limited storage. Okay, now just observe, right? Yes. Hadoop is not for Hadoop doesn't follow client server architecture. Hadoop doesn't follow client server architecture. Hadoop follows master slave architecture. Hadoop follows master slave architecture. Single master and multiple slaves, right? Yes. Single master and multiple slaves. Slave 1, slave 2, slave 3. This is what master node. Okay, master node, this entire connection of this entire thing we got like a cluster, group of nodes, CPUs connected in a network, group of systems connected in a network, right? Forming a cluster. So in a Hadoop, data is stored in the form of files, TXT files or CSV, or whatever, stored in the form of files. The file is again subdivided into blocks. So in Hadoop, if you think that this system one of 1 TB RAM, 1 TB RAM, 1 TB RAM, assume. Okay. F1.txt size is of 2 TB. This 2 TB cannot fit into any of the system set, but what we do, you will split into smaller parts and store across multiple systems and process it accordingly. Okay. So data is this two advantages we can see, right? Data is getting distributed and data is processed by multiple systems parallelly, right? Yes. So here, what are the advantages? Okay, advantages of Hadoop advantages. Unlimited data storage, right? Unlimited data storage. very high speed processing, very high speed processing because of parallel processing, right? Very high speed processing, right? Because of parallel processing, right? Yes. Because of parallel processing, and can handle all varieties, can handle all varieties of data, structured, unstructured, and semi-structured, right? Unlimited data storage, very high speed processing, can handle all varieties of data, structured, unstructured, semi-structured, right? It's an open source, no licensing required, right? Yes. Okay. Unlimited data storage, right? There is a feature like horizontally, right? Unlimited scalability, right? Yes. Horizontally, unlimited number of slaves can be added. Systems can be added, right? Pray if you're running a business with 10 systems, your business has increased, your branches are increased, your data is increased, your customers have increased, right? If data increased by 100 times, customers increased by 1,000 times, you cannot go with the same number of systems, right? You need to horizontally increase the systems from 10 to 20. Very high speed processing, right? Because of parallel processing, right? Your data is distributed across multiple machines that are processed parallelly, right? And can handle all varieties, structured, unstructured, and semi-structured. Open source, no licensing required. I'll just show you one example, right? Yes, only Yahoo has conducted a test, right? Yahoo has conducted a test. That's taken a table of 1024 of just taken a table of 1024 columns, right? Yes. Yes. Yahoo has taken a table of 1024 columns of size, the size of the table, right? Yes. 100 TB, right? 100 TB, right? Task sorting based on 16 columns. Sorting based on not one column, 16 columns, right? Time taken by different databases. Just observe this time taken. Oracle has taken nearly 3.5 days to process this, right? Yes. MySQL has taken 6 days, right? Yes, Oracle has taken 3.5 days to process this. MySQL has taken 6 days, and one specialized database like Teradata, right? It has just taken 4.5 hours, right? Another specialized database, right? Netija. Another specialized database, right? Netija use just it has taken 3 hours, right? It has just taken 3 hours, right? Fine. Teradata 4.5 hours, Netija 3 hours, and finally Hadoop has just taken 3.4 minutes, right? The latest version of Hadoop has just taken 1.2 minutes, right? This is what the speed of Hadoop has compared with other things, right? Yes, very high speed processing. As compared with other things, right? So Hadoop is proven in the market, processing point of view and storage point of view, right? Processing point of view, right? With very less time, and storage point of view also, right? It is proven in the market, right? Okay, next. Why a query, right? A query. Why databases? Why databases like Oracle cannot support unlimited storage? Cannot support unlimited storage, right? Yes. So databases in real time, even databases, right? Like Oracle can also go with multiple systems, right? Yes. Like databases and the limit, they have got some limit databases and limit on the number of slaves. Number of slaves. Limit, max limit on limit. Okay. Oracle, for Oracle, there is a limit, right? Okay, up to it can go with 256 systems, 256 nodes. Nodes means CPUs are systems, right? Beyond that, it cannot support the data for, right? For MySQL, a limit up to 54 slaves, 54 nodes are systems, right? Yes. MySQL Express can go with 256, right? Yes. DB2, even if we talk about DB2, is also going with 256 nodes, right? Yes. Oracle. Okay, even any database, right? It is not supporting more than this. Once this 256 systems gets filled, right? It cannot support data further. So none of these databases storing unlimited, right? Even if we talk specialized databases like Teradata, Teradata can go with 512, like 512 nodes. It is going with 512 nodes. Teradata is going with 512 nodes. Even another specialized database, right? Netija also can go with 512 nodes or systems, right? But currently nodes, this nodes means systems, slaves. Currently Teradata going with 1024 nodes, right? And this Netija also going with 1024 nodes, right? Yes. So, but none of these databases are specialized databases, right? Supporting unlimited storage, because once they get filled, they cannot support data further, right? But if you talk, uh, there is no limit. But for Hadoop, there is no limit on the number. There is no limit on the number of flows that Hadoop can have, right? There is no limit on the number of number of slave nodes that Hadoop can have. Okay, so there is no limit on the number of slave nodes that Hadoop can have. It can have any number of unlimited number of slaves it can have, like for Hadoop. Yahoo when first time implemented Hadoop, right? Yahoo when first time implemented Hadoop. Yahoo when first time implemented Hadoop went with 4,000 slaves, 4,000 nodes, right? When first time Yahoo when first time implemented Hadoop, it went with 4,000 slaves or nodes, right? 4,000 nodes or systems for storing its data. Currently, right? Yahoo going with Yahoo currently going with 12,000, right? 12,000 nodes for storing its data. And Facebook, right? Facebook when first time implemented Hadoop. Facebook when first time implemented Hadoop, right? It went with 8,000, right? It went with 8,000 nodes for storing its data. Currently, Facebook, currently, right? Yes. Currently, it is going with 42,000 nodes, right? 42,000 slave nodes for storing its data. Okay. So there is no limit on the number of slaves that Hadoop can have. Can go with unlimited number of slaves, right? Yes. So Hadoop is proven in the market storage point of view and processing point of view by taking very less time, right? So in the current, like we have got a great boom for Hadoop, right? Today, most of the ETL kinds of projects are getting migrated towards Hadoop environment, where like because most of the applications generating data, huge data, right? Yes. Fine. So as part of this course structure, right? Yes, as part of the course structure, right? Just you can observe this course structure, right? What I'm going to discuss as part of this, right? Big data Hadoop, right? Introduction, like what is big data Hadoop, challenges, advantages, right? Features, name node, HDFS, right? Hadoop distributed file system, metadata management, storage and processing, replications, fault tolerance, HDF and map reduce and execution model, right? Yes. Mapper phase, reducer phase, groupings and aggregations, driver and the scoop, right? For pulling the data from different data sources, from different databases, you are going to pull the data and to Hadoop environment, and later using the processing tools will process it, and again you will export the data back to databases. Again, you are going to export the data back to databases, right? Yes. So while the import operations, I can perform different things, right? Like transformings, filterings, groupings, aggregations, mergings, all that I can perform before data comes to Hadoop. I can perform all these operations, and also exporting data from, so SQOOP, the first two characters of SQL, last three characters of this Hadoop form scoop, right? Next, one more component, yarn, yet another resource negotiator from, okay, entire architecture of yarn I'll be discussing, and one NoSQL database, NoSQL, not only SQL, right? In brief, I'll be discussing about NoSQL database, right? HBase, right? HBase is a kind of NoSQL database which is especially designed for Hadoop. And Hive, one more component. Hive is a kind of data warehouse kind of environment within the Hadoop framework, where we can store the data in a structured format in the form of tables, internal tables and external tables, working with unstructured XML, JSON, URL, logs, weblog data, unions, file inserts, locals, HDFS, UDF, UDAF, UDTFs, right? Dynamic partitioning, static partitioning, dynamic multi-column partitioning, right? Yes. Indexing, bucketing, right? All this performance tuning mechanism, right? And having HBase integration, right? And coming to this PySpark, right? Spark with Python implementation. PySpark, need for PySpark, it real-time use cases, PySpark RTD computations, persistence options, right? Different ways of persisting, PySpark groupings and aggregations, various actions and transformations, PySpark SQL data frame, right? Yes. Various kind of SQL data frames, right? Yes. PySpark creating data frame, empty data frame to pandas, PySpark show, PySpark row class, column class, select, collect with column renamed, where, filter, drop duplicates, order by, sort by, union all, union by name, UDFs, right? Is a defined function. Map, flat map, for example, fill nulls, pivot, partition by, and PySpark SQL functions, right? PySpark SQL functions. One second. Aggregated functions, window functions, date and time functions, JSON functions, write entry. Excuse me. PySpark built-in functions. When, expr, lit, split, substring, translate, overlay, to date format, explode. We don't need to write huge codings, right? We have got many inbuilt functions, libraries, right? Create list, create set, create map, map keys, map values. So all this, right? Percentage rank from JSON and PySpark external sources, right? From Spark and Hive integration, Spark MySQL integration, working with JSON, CSV, narrow and wide transformations, actions on data frames, new columns, droppings, renaming, adding of new rows, handling nulls, writing data back to external sources, right? And deployment modes, local mode, clustered mode, PySpark application, stages and tasks, driver and executor, right? Building Spark application, right? On deploying Spark applications to cluster and tuning and performance tuning, and PySpark streaming concepts, integration with Kafka. And also I'm going to give knowledge on Flume and Kafka, streaming, right? And live streaming, right? Streaming means streaming data means data which keeps on generating, data which keeps on incrementing, right? Such kind of data we call it like streaming data, right? Yes. Yeah. So that is what we have discussed in brief, right? All these things, like I said, it's a 12 weekend batch, right? So mostly like first 5 weekends I'll be discussing on Hadoop, next 7 weekends on Spark, PySpark, right? It has got high boom today in today's market, right? Yes. Now, yes. In PySpark, right? Okay.
Hello.
Yes, yes.
Sir, good evening. So in a cluster, if some nodes are crashed, so the data will be also crashed. So how we get ready from that?
We have got a concept of replication and fault tolerance, right? We have got the concept of replication and fault tolerance.
Yeah, no, sir. I have just a tracer and I just browse.
What is it?
Sir, I am a tracer, so I just get some doubts.
Yeah. I'll just brief you about this. How exactly the data stored and how exactly data processed And if any particular system goes down, if there is a data loss, how it can be overcome. I'll just brief you about it, right? Yes.
Sir, what is the meaning of the main node, master node? This
Node.
mean, yeah, master nodes.
So here a group of nodes connected in a network means systems. So all the systems are interconnected. One will be the master, all the remaining will be the slaves. Master node will be highly configured. All the others will be the slave nodes. So master
Slave means CPUs.
slave nodes means, okay, one second. Single master. Okay. Single master and multiple slave nodes. Okay. System 1, system 2, system 3, system 4. Totally, we call this like a 5-node cluster. In this 5-node cluster, the 1 will be as the master, remaining 4 will be as the slave nodes. These slave nodes will store data and process the data. And this master node will store the metadata, data about data. And this master node assigns the task to the slaves. Master nodes, if any system goes down, then the task of it will assign to any of the other system that is done by the master node. We call it as like fault tolerance mechanism, right? Yes.
Sir, metadata means?
Metadata means data means, for example, your data file f1.txt. Metadata means about the files, schema, or if you talk about the file blocks, file is divided into multiple blocks, fixed size blocks. Each block in this means if this file blocks is divided into how many blocks, the blocks are stored in which slaves and which I need to trigger, so that everything will be within the master node about this particular file, into how many blocks it is divided, and each first block stored in which slave, second block, everything, that information, everything will be within the master node. So tomorrow, if it wants to retrieve the data of this f1.txt, it has to combine all this, right? So for combining, it is present in which slaves, right? Okay, fine. Fine. How exactly data stored and processed, right? How exactly data stored and processed within this Hadoop? Just I'll take some time more before we go with the break. Okay. Okay. So otherwise, we do one thing. We'll have a 15 minutes of break, right? Again, we'll come back. We'll discuss on the Spark, importance of Spark today, importance of PySpark, Spark with Python, and also how exactly data stored and processed. Everything I'll be briefing you, right? Just at we'll just meet at 4:50 again, right? Just 10 minutes. We'll have a break and we'll be back at 4:50. Just I'll keep the meeting in the mute. If you come back again, I will come back with you. If you got any queries, you can ask me the queries. And before that, I'll be briefing you about Spark importance and how exactly data storage and processing happens, right? And again, we'll be continuing for after the break. Again, we'll have one more break. We'll be continuing totally 3 hours of session, right? Yes. Fine. Okay. So 1 second. PySpark, right? Discussing about PySpark. I can say PySpark is an open source distributed cluster computing framework, which was introduced by Apache Software Foundation. PySpark, right? For big data analysis, for processing, and for computation, right? Yes. You can say PySpark is a Python API to use Spark. It's a Python API to use Spark. Observe this. Spark. Spark is a open source cluster computing distributed in-memory computation with parallel process and with in-memory computation feature, right? Okay, open source cluster computed and distributed, right, with parallel process and in-memory computation. The main feature what we see in Spark is in-memory computation means, right, within the memory only we are going to store, within the memory only we are going to process. Yes. PySpark is used for distributed SQL, for creating data pipelines, data ingestion into database, machine learning algorithms, and for graph and data streams. Yes. So PySpark is a lightning fast technology that is designed for fast computation. It is one of the very demanding tool among the data engineers, right, to work with bigger data sets. It is used, right, as I said, it is used for running these distributed SQLs. Okay. So if you talk about the need for PySpark, right, yes. Large amount of data is generated, right, both offline and online. Right. This data contains hidden patterns, unknown corrections, market trends, customer preferences, right, and other useful information, right. So it is used to extract valuable information from the raw data, right. So we require a more efficient tool. We require a more efficient tool, right, to perform different types of operations. Perform different types of on the big data, right. So there are many tools, there are various tools already available, right, to perform these multiple tasks to hedge data sets, right, but those tools are not so much of appealing, right. So we need to have some scalable and flexible tools to crack this big data and to gain benefit from it, right. So PySpark is such a kind of tool. So the combination of Python and Spark, will be the very efficient way for the world of big data. That's why Apache Software Foundation, right, it came up with a tool like PySpark, that is Python API for using Spark. Spark is an execution model implemented by using a language like Python, right? Yes. So here we see most of them will have whether to go with Spark with Python or Spark with Scala, right? Yes. Difference between Python and Scala, right? Python is dynamic. Python supports dynamic types. So if you say X has 10, Y has 4.5, Z has hello, right? What value you are assigning, right? Based on the value assigned, the variable gets created. If you are assigning integer value, integer variable creates. If you are assigning a float value, float variable creates. If you are assigning a string value, string variable creates. Okay. Python has a huge community, right? Python has a huge community, but Scala has a smaller community as compared with it. Python supports nearly 89,300 modules as but libraries, Scala libraries are less as compared with Python. And one thing, Scala is faster than Python. Python is a little slower as compared with Scala, right? Okay. Real life usage of Spark, right? Yes, it's mostly used in the commercial sector, right? Yes. Commercial, it uses Apache Spark for real-time processing, right? Banks and other financial fields will use Spark to retrieve customer social media profile and to extract information related to credit risk assessment, right? And also Spark plays a vital role in fraud detection, right? And in healthcare, right, to analyze the patient's records along with the previous medical reports to identify which patient is mostly like to face the issue, right, even after being discharged from the clinic, right? And the entertainment industry, right, today everything we are, so the total entertainment industry which is growing towards the online streaming. The popular online entertainment platform Netflix using Apache Spark for real-time processing. Use for, okay, so for personalized online movies or web series, right? Series Netflix process nearly 450 billion events per day that streamed over server-side applications, even within the trade and e-commerce side also, right? Like websites like Flipkart, Amazon, all this, they use Apache Spark for this advertising. They use Apache Spark for advertising, right? Yes. And in tourism industry also, advising the millions of travelers by comparing hundreds of tourism websites, right? And if we talk about the features of Spark, okay, features of PySpark, right? Yes. In-memory computation, right? In-memory computation, right? Means data is stored within the memory and data is processed by the within the memory, right? Spark is lazy evoluted or active evolution, or lazy evolution means which one? Spark follows lazy evolution only. Lazy evolution means whenever you declare something, it is not going to get executed. Here in Spark, we have got a data flows. The data flows immediately you declare, it won't be executed. If you make an action, then only data flow gets executed. Okay. In-memory computation, lazy evoluted, fault tolerance, right? Fault tolerance means whenever Spark data is stored on different systems and are processed parallelly, suddenly if any system fails, right, then Spark has got powerful fault tolerance model. Persistence means if you already executed transformations output, we can reuse it, right? That's what we call, if you persist that, then we can reuse it. It is distributed and parallel process, right? It's parallel process time. Fine, right? So Spark speed is faster than Hadoop speed, right? Spark is okay. Now, how exactly data stored and processed, right? How exactly we are storing data and processing the data, right? Yes. Okay. Data is stored in Hadoop. Data is stored in the form of files. Each file is again subdivided into fixed size block. Default size is 64 MB, but in the latest version, right, default block size is 128 MB, right? Observe here, right? How exactly data stored and processed within Hadoop means, if we take, I have got a file f1.txt. File name is what? f1.txt. Excuse me. Assume the size is 192 MB. Default block size. Default block size equal to 64 MB. Number of blocks Number of blocks equal to size by default block size. One 92 by 64. How many blocks? B1, B2, and B3 blocks. B1 64 MB, B2 64 MB, B3 64 MB. Okay, 64 MB, 64 MB, and 64 MB, right? Yes. Okay. It is stored in system 1, system 2, and system 3. Observe here. Okay, how exactly it is stored, right? Yes. Master, and these are slaves. Slave 1, slave 2, and slave 3. B1 block here, B2 block here, B3 block here. So if the number of, see here, a file always divides into blocks. How many blocks depends on the default block size? Here 3 blocks. If the number of blocks if number of blocks equal to number of slaves, systems, 3 blocks equal to 3 systems, right? Very high speed, right? Yes. Okay, in Hadoop, this is the master node, right? It stores the metadata, data about data. It won't store data about data. F1.txt divided into 3 blocks: B1, B2, B3. B1 stored by slave 1, B2 by slave 2, slave 3. Think that here 192 MB, 30 lakh records. 10 lakh in this, 10 lakh in this, 10 lakh in this. This is how exactly data stored, right? How exactly data stored. Data, if you take any file, divides into blocks. Default blocks as if it is 64 MB, right? So 64 MB, 64, 64, right? Yes, 192. Data processing, right? Data processing. Data processing means your job to process f1.txt. f1.txt, right? Yes. Job to process f1.txt. How many tasks? Number of tasks, right? Number of tasks always depends on number of unique blocks, right? Number of unique blocks. Number of tasks, how? Okay. Number of unique blocks, how many here? 3 blocks. 3 blocks, right? B1, B2, B3. 3 blocks means 3 tasks. T1, T2, and T3. T1, T2, and T3. 3 tasks, right? Yes. Yes, the Hadoop gets integrated with cloud systems means yes. Yes. Now job is to process f1.txt, right? Job is to process f1.txt divided into tasks T1, T2, and T3. 3 tasks. T1 to execute what? T1. T2 to execute what? For executing T1 task for executing, right? For executing B1. T2 is for executing B2. T3 is for executing. Okay. Who should execute this T1 task? Who should execute this Fs? Yes. Who should execute this T1 task means slay system one only, right? Because B1 block is present in system one only need to execute. T2 task to be executed by S2, T3 by S3, right? All these three tasks, T1, T2, T3 are executed parallelly, are executed three tasks are executed parallelly by three slaves. Three tasks are executed parallelly by three slaves S1, S2, S3. So here T1 tasks to slave 1, T2 to S2, T3 to S3. Three tasks are executed parallelly by three slaves, right? And gives the output to this, right? So here none of these tasks are in the waiting state, right? But if you observe this case 2, observe this case 2, right? Number of blocks are greater than number of systems. Blocks are 3. Blocks are 4. Two systems. Two systems, right? F1.txt file. Assume that 230 MB. To the T by 64 MB, right? Number of blocks is 230 by 64 MB, right? You will get what? 4 blocks. Four blocks, right? B1, B2, B3, and B4. But only number of systems are 2. This is the system master and only 2 slaves. B1, B2, B3, B4, right? This is slave 1, this is slave 2, right? Within the slave 1, slave 2, this is the master node. Stores the metadata, right? F1.txt into B1, B2, B3, B4. It allows the knowledge, right? B1 stored in slave 1, B2 in slave 2, B3 in slave 3, B4 in slave 4. Okay. This how exactly data stored. Now data processing, right? Data processing means your job is to process f1.txt, right, into number of tasks. In Hadoop, how many tasks to process it? Number of tasks always depends on number of unique blocks. Number of unique blocks are 4. Number of unique blocks are 4. F1.txt, right? Yes, to process. We have what? 4 tasks, T1, T2, T3, T4. T1 is for executing B1, T2 is for executing B2, T3 is for executing B3, T4 for executing B4. Who should execute this T1 task? Who should execute this T1 task? Everyone try to answer. System 1 or system 2? Slave 1 or slave 2? Yes, because B1 block is present in slave 1. Who should execute this? System 1 or system 2? Slave 1 or slave 2? Yeah, slave 1 only, right? There's no other choice. Because B1 blocks, task 1 is to execute B1. B1 present in S1 only. And T2 by S2. T3 again by S1. T4 by S2. Okay. Yes. So here, if you observe carefully, S1, S2, S1 executing what? T1 and T3. T2 and T4. So here, when in S1, T1 is executing, T3 will be in waiting. In S2, when T2 is executing, T4 will be waiting. Okay. Once T1 is executing, T3 will be the waiting. T2 is executing in slave 2, T4 will be waiting. Means here only this T1, T2 executing parallelly. T3, T4 are in the waiting state. Once the T1, T2 execution completed, next T3, T4 means some of the tasks are in the waiting state right here. Right. Yes. If only one slave, here 2 slaves, but if there's only one slave means all the tasks need to be executed by the single machine, right? Slave, one after the other sequentially. Right? Yes. Yes. Just before someone asks a query, right? I go back to case 1. If any one system is down, S1, S2, S3, right? If suddenly if system 2 is down, 10 lakh records lost, there is data lost, and a T2 task is failed means job also failed, right? How Hadoop is able to overcome this kind of situation means, right? Replication and fault tolerance. We have got replication and fault tolerance. Replication means duplication. Replication means what? Duplication, right? Yes. In Hadoop, default number of replications, default number of replications equal to how many replications? 3. Okay. Default, but we can also increase or decrease, right? We can also increase or decrease the replication. We can also increase or decrease the block size also. Okay, I'll show you what you mean by replication and fault tolerance. F1.txt 192 MB, number of blocks, three blocks. Three blocks means B1, B2, and B3. B1 replicated by 3, B2 replicated by 3, B3 also replicated by 3. Totally how many blocks? 9 blocks. 9 blocks distributed across 3 slaves. Assume we have got 3 systems. B1, B2, B3. B1, okay. So this 9 blocks, B1 here, B2 here. 9 blocks are distributed across the 3 slaves. Here master node f1.txt stored into B1, B2, and B3. Where B1 stored in this one, B2 in S2, B3 in S3. B1 is stored in slave 1, slave 2, slave 3 here. B1, B1, B1. B2 also in S2, S1, S3. Yes. All the blocks, okay. Now, data processing, right? Data processing. Data processing means task to process f1.txt, number of tasks, number of blocks. Number of unique tasks, 3 blocks, 3 tasks, T1, T2, and T3. Okay, job to process f1.txt, right? T1 task, T2 task, T3 task. T1 for executing B1, T2 for executing B2, T3 for executing B3. Yes. Here who should execute T1 means slave 1, T2 S2, T3 by S3. Okay, so if T1 is executed by system 1, T2 by S2, T3 by S3, if this S2 is down, do you think any data loss here? Do you think any data loss here? Still T2 is for executing B2. B2 is still present in S1 and S3, right? There won't be any data loss, right? Yes. Okay. S1, S2, S3. So here still if this is fun, still the B2 data is available, still if S1 also is down, still B1, B2, B3 all present in S3, there is no data loss. If 32 tasks can be assigned to S1 or S3, right? So what is the criteria followed in assigning the T2 task to S1 or S3? Or here S1, S2, S3, all these three can execute this T1 task. S2, S1, S3, S3, S1, S2, all these three can execute, right? Why only T1 task is assigned to S1? What is the criteria followed in assigning the task to the slaves, right? Yes. You can see that the 4 steps criteria, right? So to which one? If T2, if this particular slave is done, T2 task to be assigned to whom? T1 or yes. So it's a 4 steps criteria, right? Yes. Observe this. First, if S1 executing T1, S2, T2, S3, T3. If S2 is down, right, then to S1 or S3 means master node selects the slave which is highly configured. If both S1 and S3 are equally configured, then master node selects the slave which is more ideal, more free. If both the slaves are free, then master node selects the slave which is nearest to it. If both are equally near, then selects the slave which has good health status, means even though they have got equal configuration, but health status, right? If both have got good health status, then finally it selects any one slave randomly, right? When multiple tasks T1, T2, what do you mean by fault tolerance? When multiple tasks T1, T2, T3 are executed parallelly by multiple slaves, if any one slave goes down, then the task of the slave will be assigned to any other slave. This process we call it as fault tolerance, right? Yes. Yeah. So just I was discussing about how exactly data is stored and how what is stored in data. Okay, 1 second. Okay, fine. Any queries from your side, anyone? So yes.
Hello, sir.
Yes, yes.
Yeah, sir. Suppose there are two masters and only three works, sir. How it's assigned to the task?
So in the latest versions, right, we can have multiple. So this is my. Okay, the latest versions. 1, 2, 3. One will be active, the other will be passive. So this is only will be active, this will be in passive. When this active is down, master node, this passive becomes active. If this is also down, then this becomes active. Means in this way we can have multiple masters also possible from not the recent versions. This we got this feature we call as high availability, right? Only one will be active, all won't be active, right? Okay, fine. So there is some more discussion, right? Yes. So we will also, okay, any other queries, right? So before we have, so we'll have one more break of 10 minutes, right? And we will continue for 1.5 hours more, right? Yes.
Yes, sir. How the tax will be assigned to the nodes?
Yes, that I will be discussing right after a break. So yes. Yeah,
Okay, sir.
the processing of this. Now I will be discussing on processing tasks. What are the components, right? Those things, architectural part I'll be discussing, right? So one thing, So it's the weekend batches, right? And we need to, with our limited, we have got the weekends, as I said. I need to complete this Hadoop in 5 weeks, that is 5 weekends, and Spark in 7 weekends, right? Totally 12 weekends. In brief, we'll be discussing, right? So everything you'll be understanding, right? Step by step, I'll be discussing all these things, right? So
Yes, sir. Any
this is
projector there?
this is a weekend batch. So 2.5 to 3 hours on Saturday it will be 2.5 to 3 hours, and on Sunday also it will be from 2.5 to 3 hours, right? Right.
Yes, sir.
So
Sir, so
so
any
so we,
projects?
5 hours, right? Totally like 5 hours in a week. So in that way, we'll be having like 12 weeks, 60 hours, right? So okay. So nearly like okay, fine. So so the timing of this batch, will be like 5:30 p.m. dead. It will be like 5:30 p.m. to 7:32. Like sorry, it will be like 5 p.m. to 7:30 p.m. Right? Yes. 5 p.m. to 7:30 p.m. Right? Yes. 7:30 p.m. Okay. Every week it will be so and so timing, right? 5 p.m. to 7:30 p.m. Right? So it will be on Saturday and Sunday, right? So as of now, we have got some more discussion, right? And so we'll have a break of 10 minutes. Okay, I'll just come back to our queries now itself. Before that, we'll have some break, right? And we'll just continue for 1.5 hour more discussion on this, right? And tomorrow class starts at 5 p.m. right? Class starts at okay. Now we'll have, I'll just let you know, right? Yes. Okay. Timing for the class. It's not possible in the morning. This is the time which is suitable for all the students from US timings for all those, right? This is the suitable timing, right? And it's a weekend batch. Yes, it will start at 5 p.m. Yes, it's going to start at 5. This demo was taken at 3:30 p.m. right? But it's going to start at 5 p.m. every week. Every week it's going to start at 5 p.m. That's why I'm making it clear to all, right? So it's 5 p.m. the 5 p.m. to 7:30 p.m. IST timing. So yes, it's a weekend batch. It's not a weekday batch. Yes. Yeah. So by tomorrow, right? You need to get enrolled, right? By tomorrow, you have to get enrolled. Tomorrow, the link will be changed, right? So the link is going to be changed tomorrow. Those who got enrolled will be getting the link, and a WhatsApp group will be created, right? Yes. Will be added into the WhatsApp group once you got enrolled, and clear notes will be provided, and you'll be, every session is video recorded. You'll be getting the recorded videos, right? Every session, right? Even though if you're absent, you'll be getting the recorded video. You can go through and attend the next session, right? Yes. Fine. Recorded videos, clear soft copy of the notes, WhatsApp group. This is the providing. So okay. So just we'll have it just 15 minutes of break, right? Yes. And we'll continue for 1.5 hour more, right? So we'll start at 5. We'll start the session at 5:45 p.m. Any queries before that, anyone? How many long video sessions will be available? So for 7 months, right? It will be for the next 7 months. Okay, fine. Yes. Any other queries, right? Anyone? If you've got any queries? So you can see in the chart panel, right? Yes, in the chart panel. The payment process and procedures, the mobile numbers, all the details, everything's provided in the chart panel. The second or third message, a big message is given by the online team. once you done the payment, don't forget to share the screenshot to this online, that is DurgaSoft online training. Everything you can go to the course content also. And one more thing, for the session now that what we are going to start, right? Follow this link. Okay, we have got another session in this link, but just I posted one link now, right? I just posted one link. Now follow that link, right? Follow this link. For the session is starting after 10 minutes, right? Yes. So I'm stopping here. We will continue just after 10 minutes. And just so you can just see that the new link posted in the short, you can just join it, right? It's fine.